So this video is on redox equations. And our aims for this video are to be able to write half equations for redox reactions. If you're not sure what a redox reaction is, then please watch one of the other videos on that. And to be able to combine half equations to create full equations for redox reactions. So, to write half equations for redox reactions, you just have to follow a set of rules. So if you can learn those rules and apply them in an exam, then this is actually very straightforward. So I'm just going to write out the rules on this slide first, and then I'll show you how we can use them in the next slide. So the first step for writing a half equation for redox reactions is to draw an arrow and to write the reactant on the left-hand side and the product on the right-hand side, ignoring the fact that the question might say it happens in acid solution or water might be made. All you're going to write is the reactant and product. So that's your starting point. The next step is you're going to balance any element that isn't H or O, so hydrogen or oxygen. So anything else, you're going to use big numbers in front of the reactant or product to balance any element that isn't hydrogen or oxygen. The third step is to balance oxygen by adding water, so H2O. So you can see that each water has one oxygen in, so you need to make sure you add the right number of waters in order to balance the oxygen. Don't worry about hydrogens for now, we'll balance that in the next step, so you just make sure the oxygens are balanced by adding water on the appropriate side. The next step, step 4, is to balance hydrogens by adding H plus ions. Okay, so however many H plus ions you have to add to balance the hydrogens, then do that. Make sure you take into account the hydrogens and oxygens in case of water in the product and the reactant, because sometimes they can be missed if you're just doing this quickly. So take your time with this and make sure you do it right. The fifth step is to balance the charge by adding electrons. Now remember, electrons are negatively charged, so they're going to cancel out any positive charges you might have. And all you've got to make sure that you do is to balance the charge so the charge is the same on both sides. They don't have to be zero on both sides, they just have to be the same on both sides, and we'll see that in action in the next slide. So, here's an example question. It says, to write half equations for the formation of iodine from iodide ions and for the formation of sulfur from sulfuric acid, and then hence write an overall equation for the formation of these products from iodide ions and sulfuric acid. Now, we're going to do the second step in the next slide. So we're just going to write the half equations for now, and you can see that I've put the 5 steps that I went through in the last slide above so you can see what I'm doing. So the first step is to write the reactant product on either side of an arrow. So we've got 2 half equations here, one for the formation of iodine from iodides and one for the formation of sulfur from sulfuric acid. Now the fact it said formation of iodine means that's going to be on the right-hand side of my arrow. So iodine is I2, and the formation of and it's going to be made from iodide ions, so that's I minus, and the other one is formation of sulfur from sulfuric acid. So the first thing is to make sure that your reactants and products on the right-hand sides on the right sides of the arrows, either left or the right, depending on whether they're reactants or products. The next step is to balance anything that isn't hydrogen or oxygen. So in this first equation, we haven't got any hydrogen or oxygen, we've just got iodine. And the iodine is not balanced. We've got 2 on this side, and we've only got 1 on this side. So we need to put a big 2 in front of this iodide ion to balance the iodines. In this one, we've got sulfur as our other element. We've got oxygen and hydrogen, but we're not balancing those yet, we've just got sulfur. Now you can see there's 1 sulfur on this side and 1 sulfur on this side, so those are balanced. Our next step says to balance oxygen by adding water onto the appropriate side of the arrow. So in our first equation, we haven't got any oxygen, so there's no need to add water. But in our second equation we've got 4 oxygens in sulfuric acid. So that means that the left-hand side of this arrow has got 4 oxygens, whereas the right-hand side has got none. So we've got to add 4 waters, because each water has an oxygen, so we need to add 4 of them in order to have 4 oxygens on the right-hand side of our arrow. That's the oxygens balance. So our fourth step is to balance the hydrogens by adding H plus onto the appropriate side of the arrow. So again, in the first equation we've got no hydrogens, so we can leave that one. But in the second one we've got hydrogens. Now we've got 2 hydrogens on the left-hand side, and we've now got 8 on the right-hand side due to the added water. So that means we need to have 6 more on this left-hand side. So we'll add 6 H plus onto the left-hand side of the arrow. And that's the hydrogens balanced. Finally, we've got to balance the charges by adding electrons. Now, what I would do now is to make sure that you write underneath each of the elements and ions and things in the equations, the charge in each thing, and then you can see how many electrons you need to add. So, in the first equation, we have a 2 minus charge coming from the iodine, and we've got no charge on the iodide ions. We've got 2 minus charge coming from the iodide ions, and a 0 charge on the iodine. So that means we have to add 2 electrons onto this right-hand side to bring this charge down to minus 2. So we've got to add 2 electrons onto the right-hand side in order to balance the charges. And now you can see there's also a 2 minus charge on this side. So those charges balance 2 minus on that side and 2 minus on this side. In the bottom one, we've got a 6 plus charge coming from the 6 hydrogens, because each hydrogen has a positive charge, and there's 6 of them. We've got a 0 charge coming from the sulfuric acid, 0 from the sulfur, and 0 from the water. You can see there's no charges on any of these. So that means that this side has an overall charge of 0, but this side has an overall charge of 6 plus. So we've got to bring this side down to 0 by adding 6 electrons onto this side. If we do that, then we have a 6 minus charge as well on this side, and so overall 6 minus plus the 6 plus equals 0. So now the charges are also balanced. So there's our 2 half equations by following all these rules, and that's done. So our final step in this question is to write the overall equation for the formation of these products from iodide ions and sulfuric acid. Basically that means is to combine these 2 equations in order to create the full redox reaction equation. Now, for the full equation, you don't have electrons in the equation because electrons aren't actually reactants or products. They're just, these half equations show the movement of them, if you like. So in this first equation, you can see they're being made, and the second equation, they're being used, if you like, or gained and lost, if you want to think about it in terms of oxidation and reduction. So when we combine these, we need those electrons to cancel out. So that means that we need to, like simultaneous equations in maths, we need to multiply up this top equation so that these electrons are the same. So the number of these electrons need to be 6 in order to cancel out with the bottom. So all we do is multiply this whole equation at the top by 3. So if we multiply the iodide ions by 3, we then get 6 of those, because 2 times 3 equals 6. If we multiply the iodine by 3, it's just 3, and then multiply the electrons by 3, we get 6 electrons as well. Then we can combine these 2 equations. So all we do is add all the reactants together on the reactant side of the arrow and add all the products together on the product side of the arrow. You can either write the electrons in and then cross them out afterwards, or you can just leave the electrons out altogether now because you know that they'll cancel. So the overall reaction will be 6I minus from the first equation plus 6H plus H2SO4 goes to make sulfur plus 4H2O plus 3I2. That's just me combining the 2 equations, making sure that the electrons aren't written. So the first step is to multiply up the top equation so that the electrons are the same in both equations, number of them, and then combine the two equations without writing electrons, because the electrons will cancel out as they are on both sides of the arrow. I hope that helps. Please email me if you have any questions with regards to writing redox equations.